students, I hope you all are very fine. You are living healthy and you are living safe, right? So let's start this session with a very basic topic of motion. In physics, this is a very important term. Motion, rest. Actually, rest, motion, these are relative terms. In the previous section we have discussed, physics have various branches. Mechanics is one of it, right? Mechanics can further be classified into two categories. One is statics and the other one is dynamics. In statics, we study the motion of those objects without considering the cause of its motion. While on the other hand, in dynamics, we do study the motion of objects as well as the cause of its motion and its state of rest or of uniform motion. Anyway, that we will discuss later on. But first, let's start with rest, motion and concept of a point object. And obviously in this particular episode or session, we will also discuss the types of motion. There are three types of motion which we are going to discuss. One is the one-dimensional motion, two-dimensional motion and three-dimensional motion. So, let's begin with motion. In our daily life, we observe bodies moving or roaming about here and there. Be an insect flying or an aeroplane or a ship sailing in the sea or a person moving from one place to another or vehicles flying on road, train moving on a railway track. These all are the examples of motion. Actually, there are some motion as well which are not visible to a naked eye. Like right now, molecules are randomly moving about here and there, but I can't see it, right? So, this type of motion is invisible. It can't be seen through a naked eye. Motion means the change in the position of an object with respect to its surroundings with the elapse of time or with the passage of time. What I mean to say is that, suppose this is an observation point, this is a stationary point, and this is an object, it is moving like this, right? So, with respect to its surroundings, with respect to this reference point, its position is changing, right? This is the reference point or rather observation point. So, with respect to this point, the position of this object, this moving object is changing with the passage of time. So, in that case, this body is said to be in motion. So, exactly in order to define motion, what we say is, a body is said to be in motion if it changes its position with respect to its surroundings with the passage of time. Then the body is said to be in motion. Now, let's discuss rest. It is just the antonym of motion, obviously. Rest means it won't change its position with respect to the reference point or with respect to its surroundings, even with the passage of time, right? So, a body is said to be at rest if it do not change its position with respect to its surroundings with the passage of time. So, it is then the body is said to be at rest. Here, I would like to mention one thing. Motion and rest are relative terms. Motion and rest are relative terms. What I mean to say is that everything depends on the observation point. Everything depends upon the reference which we are taking into account. What I mean to say is that no body in this universe is at absolute rest. No body in this universe is at absolute rest. Suppose this whiteboard is lying over here. For me, it is at rest. But for a man in space, the earth is rotating about its own axis. It is also having revolution. So we are also rotating along with the earth. We are also revolving along with the earth, isn't it? So for him, this is not at rest. So it is a relative term. And nobody in the universe is at absolute rest. Absolutely nobody. We know earth rotates about its own axis and it revolves around the sun. Sun is also not at rest. Sun revolves around the galactic center. It revolves around the galactic center. So what I mean to say is that nothing is at absolute rest. The body, which from one observation point may appear to be at rest, but the same body from different observation point may appear to be in motion. So basically rest and motion are relative terms. As we move on with the curriculum, we will discuss these topics in detail, right? So presently what we have discussed is motion and rest. A body is said to be in motion when it changes its position with respect to its surroundings with the passage of time, and if a body do not change its position with respect to its surroundings with the passage of time, then eventually the body is said to be at rest. Now in order to discuss the motion of an object, we need to first consider the meaning of a point object. Point object. Point object or a point particle, right? Point you are aware, this is a point having no dimensions, isn't it? Point mathematically may also be defined as a sphere whose radius approaches to 0. It can be termed as a point. So point is infinitesimally small, having no size, no dimensions at all, right? So point object. Now again, we'll talk about the reference thing, right? Point object means any object whose dimensions can be neglected. Now a bus or a train, which obviously has finite size, it's huge, but still it can be treated as point object when the distance it covers is very, very large as compared to the dimensions of the body, right? For example, I'll give you a simple illustration. The distance between Pathankot to Delhi is about 500 kilometers. Suppose I go by bus from Pathankot to Delhi. The bus, which obviously is having a finite size, but it can be treated as a point particle or a point object because it travels the distance from Pathankot to Delhi, which is very, very large as compared to the dimensions or size of the bus. So in such a scenario, bus, although having some finite size, may be treated as a point object. So understood the concept of point object. So it depends entirely with the distance that the body covers. If the distance covered by the body is very large as compared to its size or dimension, then that body may be treated as a point object, right? So now we start with the types of motion. There are basically 3 types of motion: one-dimensional motion, two-dimensional motion, and three-dimensional motion. So motion can be categorized into these 3 types. And before we bring out the essential difference between these 3, we must know that when a body moves, its position can be represented by either x-axis, y-axis and z-axis. These are known as the coordinate axis. They all are mutually perpendicular to each other. So x, y, z, these are the 3 axes which can be used to denote the position of a moving body. If the body is at rest, then all the 3 coordinates will remain constant. It won't change with time. And if the body is moving either along a straight line or in a plane or in a space, then either of these 3 coordinates or 2 or more than 2 or all the 3 coordinates may change with the passage of time. So that is what we will discuss under these topics of one-dimensional motion, two-dimensional motion and three-dimensional motion. As here the term suggests, one-dimensional motion, one-dimensional, it means that out of the 3 coordinates x, y, z, which are required to specify the position of an object, only one coordinate, either x, y or z. Out of 3, only one coordinate, if it changes with respect to time, then the motion of the body is said to be one-dimensional. Right? I'll give you an example. Suppose this is x-axis, this is y-axis, and let us consider this to be z-axis. This is z-axis actually. So I have drawn it like this. This is the origin. Suppose the body starts from point 2 and moves along the x direction. Like this. It moves along the straight line along the x direction. So with the passage of time, with the elapse of time, only the value of x will get changed. Here, if the value of x is x1, then y coordinate is 0, z coordinate is 0. And if the body is at position B at some later instant time, then here the value of x will get changed. So y and z remain constant. It can be either 0 or it can remain constant, y and z. So if a body moves along a straight path, body moving along a straight line, only one coordinate changes with the passage of time. Rest of the two coordinates remain constant. So that type of motion is said to be one-dimensional motion. So the motion of a body is said to be one-dimensional if only one coordinate out of the three coordinates required to specify its position changes with time. So let's discuss its example. So in the case of one-dimensional motion, body must move in or along a straight line. Motion of a body must be along a straight line. So that is when the motion of the body may be said to be one-dimensional, right? There are various examples. Suppose a train moving along a straight track, railway track, that is one-dimensional motion, right? Or a person moving along a straight narrow path, that is one-dimensional motion. Or another example, if I throw a ball in the vertically upward direction, right, and let's consider there is no wind, so there is no effect of air or wind, so it will move along a straight line, vertical straight line. On reaching the highest point, its velocity will become zero, and due to attraction by the earth, it will again come down along the same straight line, like this. When a body is thrown in the upward direction, in the vertically upward direction, then it will go straight, and then on reaching the highest point, it will retrace its path in the opposite direction. So it is moving along a straight line. So this is again an example of one-dimensional motion, right? Let's discuss two-dimensional motion. Again, how many coordinates are required to specify the position of an object? 3 coordinates. Which are they? X-axis, Y-axis and Z-axis. Out of these 3 coordinates, if 2 coordinates are required to specify the position of an object, then the motion is said to be two-dimensional. So, a body is said to possess two-dimensional motion if out of the 3 coordinates required to specify its position, the 2 coordinates changes with the passage of time. So, out of x, y, z, any 2 coordinate, if their value changes with time, then the motion must be two-dimensional. In this case, the body must be moving on a plane. So, it is two-dimensional case. It must be moving on a plane. I will give you an illustration. Suppose again, this is the x-axis, this is y-axis, and this is z-axis. This is the origin. This is z-axis actually. On a two-dimensional board, this is represented as z-axis. Z-axis is this one. So this one will become, this horizontal plane will become xz plane, right? So I am representing it with this shaded line. This is xz plane. This is xz plane. At any point on the xz plane, y coordinate will always remain 0. That is, it will remain constant. Suppose this is the floor of the room. This is the floor of the room. And let us consider this to be point A and this to be point B. A body is moving along this. A body is moving on the plane, following any path. It is moving on a plane. Suppose an insect crawling on the floor of a room. So over here what happens is, it will have certain value of x, it will have value of y as 0 and will have certain value of z. Over here, value of x will get changed, the value of y will remain 0. On the xy plane, on the xz plane, the value of y is always 0. Obviously, the value of z will get changed. So here you can notice the 2 coordinates, x and z, they are changing its value when the body moves from one point to another point. But the third coordinate, its value remains constant. So whenever it happens that during the motion of a body, 2 coordinates changes with the passage of time, then that motion must be two-dimensional motion. I've given an example, an insect crawling on the floor of a room, or the motion of a billiards ball on a billiards table, or the motion of a coin on a carom board. That may be termed as two-dimensional motion. I hope it's absolutely clear. Okay. Now third one, three-dimensional motion. Means it is that type of motion in which all the three coordinates required to specify the position of an object changes with the passage of time. All the three coordinates x, y, z, all the three will change with passage of time. Such motion is said to be three-dimensional motion. So it can take place only in space. Here, one-dimensional motion, body must move along a straight line. Here, in two-dimensional motion, the body must move along a plane. And in three-dimensional motion, the body must move in space, right? And all the three coordinates must change with the passage of time. I'll give you an illustration. Suppose this is x coordinate, this is y coordinate, and let us consider this to be z coordinate. Again, this is z coordinate, right? Body is moving in space. Suppose this point A, anywhere, this is z axis, x coordinate, y coordinate, and this is z axis, and body is anywhere in space. And it is moving in space, and it comes at some final point over here. So A, suppose it has coordinate of x1, y1, z1. And after some time, it is at point B where the coordinates are x2, y2, z2. All the three coordinates, the value of all the three coordinates required to specify the position of the object changes with respect to time or with the passage of time. Such motion is said to be three-dimensional. So in the three-dimensional motion, body must move in space. One-dimensional, the body must move along a straight path. In two-dimensional motion, the body must move on a plane. In three-dimensional motion, the body must move in space. There are various examples. The case of a flying bird, right? The motion of a kite. The motion of a kite, that's an example of three-dimensional motion. Then, the motion of gas molecules, which are random. They move randomly about here and there. They follow zigzag path in space. So that is three-dimensional motion. In all these examples, all the three coordinates required to specify its position changes with respect to time. So such type of motion is said to be three-dimensional motion, right? Let's discuss some important situation. Can you tell me the revolution of Earth around the Sun? Can you identify which type of motion is this? Whether it is one-dimensional, two-dimensional or three-dimensional? Just try to think over it. What I've said is, consider the case of revolution of Earth around the Sun. Case of revolution of Earth around the Sun. I'll tell you. This is Sun. This is the elliptical path which the Earth follows, right? This is the Earth. Earth rotates about its own axis as well as it revolves around the Sun in a particular orbit, right? So this is the orbit of the Earth. So which type of motion is this? Is it one-dimensional, two-dimensional, or three-dimensional motion? Can you just give me the answer? Or just think over it. Just think over it. Which type of motion are we talking about? So, suppose this is Sun. Let us consider this to be Sun and this is Earth. It is revolving like this. It is revolving like this. Right? So, it is having motion on a plane. It is not revolving like this. It is not, all the three coordinates are not changing its value with the passage of time. Instead, it is moving in a plane. This is known as the orbital plane. This is known as the orbital plane. So the revolution of Earth around the Sun is an example of motion of a body on a plane. So it must be two-dimensional motion. It must be two-dimensional motion. Clear? Okay. Let's consider some other interesting situations. Like during the landing or taking off of an airplane. Suppose during taking off, it is moving on a runway before takeoff. So the plane is moving on a straight line or straight path. That's one-dimensional motion. But as it starts taking off, like this, as it starts taking off, it is moving in this plane. So its motion becomes two-dimensional. Its motion becomes two-dimensional, right? And suppose the plane, after taking off, it is in the autopilot mode and it is moving like this along a straight path and maintaining the same altitude, and along the same straight path. So it must be one-dimensional motion. And if the pilot is doing some sort of maneuvering, or rather the plane is doing some sort of aerobatics, like this, the plane is swinging like this, the plane is doing like this, right? So that will be the case of three-dimensional motion. So we are dealing with the same case, the motion of an aeroplane, but it can be one-dimensional, two-dimensional, and three-dimensional, depending upon the situation which you are dealing with. Whether it is running on a runway, or whether it is taking off, or whether it is moving along a straight path maintaining the same altitude, or whether it is doing some sort of aerobatics. Right? So it all depends upon the situation. These are the examples which you need to understand properly. It is only then you will be able to appreciate the difference between 1D, 2D and 3D motion. Right? I hope you have understood the topic. So for this session, it is more than sufficient. Next topic we will continue in the next lecture.